nanohub.org.
Online simulation and more for nanotechnology.
So last panel, our breakout was on cyber and autonomy. We were a pretty small group and kind of a very diverse group, actually, including people from biology, and then me from aerospace, people from high-performance computing, and then also computer scientists. So that's kind of our background. I want to highlight just a couple of very quick things, and I promise you it won't actually take half an hour. So towards the end of our discussion, I asked the group, so what, if I can only say 3 things, what would I say? And they said, is that a hypothetical question, or is that like a short-term goal? So I said it was a short-term goal. And so one of the things we came up with was that autonomous systems must understand human goals. And to illustrate that idea, I'll tell you 2 kinds of stories. And so the first one is about, if you think about a system that might degrade gracefully. So you might have a computer system, and maybe it's able to limp along. And you might think that's a good thing, so it's kind of keeping going. So if I were thinking about a person being able to limp along versus, just dying on the battlefield, that might be nice. But in some cases, depending on the user, having a system that's limping along may be worse. So maybe a particular user wants a system that is 0 or 1. An example might be in financial trading, where if you have a computer system that is doing automated trading, if it's limping along and trading stupidly, or trading slowly, or trading with delays, that's worse than not participating in those trades at all. So you rather want to knock that limping along system out and have it completely out of the system. So the autonomous system and the developers of the autonomous systems must understand what the particular goals of the humans are. And something like graceful degradation, though on the surface may appear to be universal good, may not always be the right thing to do. So that's one aspect of it. In terms of thinking as well about autonomous systems working together with humans, another kind of nice anecdote that one of our members came up with was the intern analogy. So when you're working with an intern, or as I'm working with new students, a new graduate student, for example, in the beginning, I give them some very tightly controlled tasks, and I watch them very closely. So they have very little freedom to act. And then as I get to know them, then I give them more latitude and I give them more complicated challenges to work on. And so we would like to, if you can have the human and the autonomous system kind of learn and get to know each other together, then that could be a productive way to go forward. And then ultimately you get to that kind of point where, I think we all know the people that we trust, sometimes they might be doing things that we don't really understand why they've done a particular thing, but we trust them. And so we're like, I don't really know what you're doing, but I trust you, so I know that you must have a good reason for doing that. And so we would like our autonomous systems to develop to be that kind of person, whereas other people in our lives, when they do something that we don't understand, we're immediately going to jump on that and say, hey, what are you doing? You need to explain to me what is going on right here. So we don't give them that leeway because we haven't developed that kind of trust in them. So, and then I think I have 2 more things. And then actually speaking about people in our lives, another kind of interesting idea that came up was, can we use autonomy to reduce dependence on particular people? So, if you have a company where you have like the irreplaceable guy, so can we use autonomy to kind of capture maybe some of that knowledge and to make it so we don't have these critical nodes, critical people in our organizations? And then a couple more points we talked about: systems that can understand when they are being attacked and can migrate or defend themselves when they're being attacked, so that we can actually respond to that in an active way, as opposed to just maybe passively taking the attack. And then the last point I'll mention is the idea of one of the fundamental differences between cyber and physical. If I've picked a physical lock, then now I'm inside that particular room. If I figure out how to pick a cyber lock, now I can maybe be inside 1 million rooms, because that cyber lock is replicated across many places. So sometimes it can be a nice thing for us. So if I figure out a particular challenge, let's say in autonomous vehicles, and I figure out how to make them avoid a certain type of crash, I can immediately propagate that across millions or tens of millions of vehicles. So we don't have to deal with teenagers all making the same driving mistake year after year. So we can eliminate that kind of mistake in our autonomous vehicles. But on the other side, if we have a weakness or a vulnerability, then that is across all of our cars. And we could imagine something's going very badly on a given day, or with a malicious attacker, we could suddenly have all our cars kidnap us. So, and that's where I'll end. Thank you.